So let's see the overall plan of OTP based login with AI agent. The plan of this video is to start with the run of this project, then how semantic kernel code, so that's the code that how it works, set up and organized, and after that I'll explain the source code. So this is the whole plan. The source code I have given on GitHub. You can see the link in the description about the GitHub link. So the source code can be seen from there. OTP based login with AI agent. We shall do this project with semantic kernel of Microsoft, and I have already created a project. I will show you how it runs. So this is the project. This has been completed already. I will now run it and show it's working first. So let's run it first to see how it works. This is what opens. So sure, let's get. Could you please provide your phone number? The agent has asked the phone number. I'll enter any phone number that has not been already registered. On submit, the call goes to the AI agent. It seems this is very intelligent now. It says not registered. Would you like to get it registered? If yes, could you provide your name also? So I'll say yes, I want to get registered and my name is, I will now type my name. My name is Hovan XYZ and I'll submit it. This goes to the agent and the agent will respond. It takes time because I'm using a free version. So great, it knows my name also. Now your phone number has been successfully registered and OTP has been sent. I'll enter 1234 as the OTP. So everything is clear to the agent and I have sent my OTP and you are logged in. So it takes me to the members page. This is how it's actually working. Steps to an AI agent with semantic kernel. We'll see the programming part, like how to give commands. So first of all, you will need keys for your OpenAPI. You can go to this link or you can see this. This is what you will see there. You can see this video also. All the links are in the description. So all these steps, this is the first step, that you will need to get your keys and everything required. This is the video that I am talking about. The link is in the description and this is the GitHub. This is the GitHub page where, okay, I'll demonstrate. Select 4O and use this model. Language as C#, and on this page you will find a lot of information. You will get the required this endpoint credential key I will give in a moment. The key I'll give in a moment, and then the model. You will need all these three things for your coding. Create personal access token. It will ask you to authenticate once again, and when you log in you can enter all the data that you will have for your token. Now this is very important that your permission should be read only to your model. If it is not there, then you can use add permissions and then generate token. I'll not generate because I have already generated. So this is one thing that you will need. So all these free have limits on requests per minute, so things will be slower when you run. So for free these are limited. You will need paid account, but let's do with free. One thing you will need is get kernel instance. To get the kernel instance, you will need to install these packages. This is Azure AI Inference. This is the place where all this documentation is available. So this is the page that will have various options depending on the key you have. The above inference is for the GitHub free tokens that I have explained above. So this is for those. For others, you will have to visit this page. Various options are there, but I'll open it also. So this is the page that I'm talking about, and you can scroll down the page. You can keep scrolling and you will find various options. So maybe you get paid keys. In that case, you will need to adjust your packages. Semantic kernel supports various suppliers. Other things on this page you can read. So this is the documentation they have given. You can read, but I will explain all this in this tutorial. So let's come back. This is the code extract that I have given. Endpoint, you will enter this API key and model ID. So this is where you will use them, and then you will have to add this kernel as a transient. This is for ASPNET Core that I am showing. So to dependency injection we have added the kernel. So this is how the kernel will be used. I will be showing the complete project sometime soon, but let's first of all see the code part. Create chat completion agent. This is the next thing you will need. Chat completion agent, it is completed with the template. I'll explain in a moment. Then this is the kernel that you just created. The kernel is used here. Arguments, this auto will be used for function choice behavior. Other options are there. You can see the documentation. Then you will need to create a plugin. I'll explain in a moment. So this login plugin and this part, let me explain the finer parts here. First of all, this login plugin, it contains many functions that your model will ask you to select automatically. Semantic kernel will select. So from DI container, and then this is the kernel function name, the description. This is used by the model to select. The details of the function have to be written by you, and this messages they are sent to the model for further actions. This is all automated process. So you will need to write any class decorated with kernel function description. Complete code I'll show later. Then this YAML prompt string, this includes the instructions. This whole text is read through some program, C# read all text function, and this is supplied here. So we have the instructions for the template and everything. Now finally we will need chat history and chat completion thread. A chat history object, it has to be cached somewhere because it contains all the chat. This agent thread, you can pass any ID, and this is the chat history object that goes to the chat agent thread. Then this is your chat message, the chat text, your message. This is sent to the remote agent, whatever you want to ask it. A string builder is used to obtain the response, invoke async. This agent is your kernel that we showed just now. So this is your agent, chat completion agent, and all the parameters are passed. Once your string is ready, you can send it in the form of a result, and this chat history contains the updated chat history which is cached and then available for the next question. This is the response that you send, that you receive, and you can use it for whatever you want. So this is all. Let's now see the explanation of the source code. This explanation is what is where type of explanation. You will need to understand it yourself. This is important. I can only explain certain parts. So let me open the Solution Explorer. This is the program.cs file. The list of packages to be installed is given here. The code is on GitHub. You can see there also. Then we have, this is the authorization folder, the folder in areas, and this filter for adding your own anti-forgery token is required for AJAX post requests that we have to make in our project. Then we have the cookies for authentication, and after that we have add a singleton for login plugin. This login plugin I will explain later also. It is located here. This login plugin contains various functions for login, and then these are the properties: endpoint, API key, model ID. They are used in Azure AI Inference Chat Completion. I have already explained what these are. This is where model ID, API key, and endpoint are used. And here it is finally that the kernel is created. This is the kernel. It is added as a transient because kernel is lightweight and the team recommends that it can be added as a transient. So the remaining is like that as usual. Let's now see the other parts. This is a JS file. It is a helper file for making the requests to. So this is the class, and this is the post message function. It receives the URL of the page on which it is located. This function will be called from index page or whatever page, and this is the message that you want to send to the model. This comes from a text box located on the page. So an AJAX call of this data is made, and then this is the window fetch function, the request verification token, the one I showed you at the start. So this is added by us through the filter in the program.cs file you must have seen. This is the body, the text message, and the chat history. This chat history is to be sent and it is cached in this object only as a property. Towards the end you can see the chat history is cached as a property and it is sent to the model. After this, let's have a look at the YAML for login prompt. This contains your instructions to the agent. You will have to apply a lot of mind to understand what goes where, but I can show you what has been done where. Now this is the login plugin. This can be any class. It receives these through dependency injection, and all your code moves into this class. It must be annotated kernel function, any name of the function. This is a description. This description is sent to the model by your semantic kernel, and you can see we make use of database code, and then whatever it returns is also ultimately sent to the model, the remote model. And this is the code that you execute. This is executed by our class. These are sent to the remote model, and model will decide which function to call on the basis of description and the returns. This is how actually semantic kernel and the whole story is operating, as I have already explained. There are other functions like register phone, send OTP, and any function required for the login process. Then this is another class. This is a helper class. This contains a function called get chat response from model, and this is the only function in this class. It receives kernel, chat history, chat text, YAML string, plugins. The login plugin, for example, it receives as an array. Maybe other plugins are required since this is a general function that I have written. So here you create the chat completion agent and you add the plugins to the kernel. These are added from the array. From this array of plugins, this is just a helper function. Then there is a chat history agent. Chat message contains this chat text, your message that goes to the remote, and this is where the response comes from the agent invoke async. This is the response, and it is collected in a string builder, and finally it is sent. After this is the areas folder that shows you are logged in the home page of the user. Home page. And after this you have filter for anti-forgery. The one I told on the program.cs file, request verification token for the AJAX call. These are the models, and on the login page, so you can see the code is much simplified. AI assisted login OTP during testing is this. If you believe me, the code is very simplified, and this is the JavaScript onload, the spinner and all hide and show logic. Let's now run it once again to see. So this is it's already logged in because I must have used already. So let me clear the login cookie. This cookie will delete so that we can show the login process again. So we are on the AI assisted login. So this is what it says. OTP during testing is, and could you please provide me with your phone number to proceed. So this is all coming from the model. So we are typing our phone number. and submit. It says it seems your phone number is not registered. Would you like to get registered? If yes, please share your name with me. So this all is coming. So okay, register me as XYZ, and I don't remember my phone, so I'll say my phone is my phone is already with you. So this is what we have sent. Submit. Hi XYZ, you are now registered. I have sent an OTP to your phone. OTP is 1234. Submit it, and you are logged in. So this is how the whole story is operating. Thank you.